I'm Trevor Chatham, and I have the privilege of sharing with you today some information regarding telomere biology and an amazing new 100% natural product that in 2013 was approved and listed by the Australian Government Therapeutic Goods Administration. I was first introduced to telomere biology in May 2011, and as a qualified veterinarian, I was fascinated by the science and initially spent 9 days of intensive research studying the topic and the people behind it. Following this in-depth research, I was so convinced about the potential benefits of consuming the product that I phoned Kathy Cooper, one of the owners of the company that had produced it, and suggested strongly that they find a way to get it into Australia as soon as possible. I said, I turned 60 at the end of the year, and I can't afford to wait. My wife Linda and I have now been consuming the product since August 2011 when it was released, and just like thousands of others around the world are feeling much healthier and more energetic. Since 2011, I have continued researching telomere biology and have spoken to hundreds of people who have been consuming the product. The more I learn about the science and the more incredible testimonies I hear, the more excited I get regarding the potential of this new area of science to help us all to maintain our health and to age youthfully. The science is real and the product works. In this presentation, I'm going to divide it into 2 parts. The first, we're going to cover the science and all the relevant scientific information that's readily available on the internet regarding aging and telomere biology. And in the second section, we'll cover specific information regarding the product, and also we'll hear from some people that have actually been using the product. Hundreds of scientists have performed thousands of research experiments over the last 50 years or more to enable us to understand just how important and significant telomeres are to the whole aging process. The Nobel Prize in Physiology or Medicine in 2009 was awarded for how chromosomes are protected by telomeres and the enzyme telomerase. Dr. Bill Andrews was one of the co-discoverers of human telomerase. He was awarded 2nd place for National Inventor of the Year in 1997 for discovering telomerase. He's been named on 35 US-issued telomerase patents. He's certainly a world-leading biologist in telomere research. He's also a brilliant educator and lecturer. And one of the things that always amazed me was, why would a guy spend his life trying to cure aging? Well, basically, it was because as a child, Bill's father had said to him numerous times, son, when you grow up, why don't you become a doctor and cure aging? I'm very honoured to be able to say that today, Dr. Bill Andrews and I are now friends and we communicate regularly. I'm very grateful that Bill has allowed me to share with you a lecture he presented to a group of anti-aging medical specialists at their 2009 conference. The American Academy of Anti-Aging Medicine represents 26,000 physicians and scientists from 120 countries.
Dr. Andrews leads the scientific research and development function of Sierra Sciences. His team is now pursuing direct molecular approaches to temporarily activate telomerase expression and is performing discovery efforts. While director of the molecular biology at Geron Corporation, he was one of the principal discoverers of the telomerase gene. I'm proud to introduce Dr. William H. Andrews.
Groucho Marx once said, I intend to live forever, or die trying. He was trying to be funny when he said this, and he got a lot of laughs. But I don't believe the people in this room think this is very funny, because we're here because we're all trying to live forever. I know I am. And we are going to try our best to do that. And so what I'm going to be talking today isn't really how to live forever. I'm going to be talking about how to try to live forever. I'm going to be talking about research science that's underway now that's going to allow us or increases our chances of succeeding at this. And so pretty much what I'm going to be talking about today is not what you can buy today. In some cases that's not true. But I'm going to be talking about what's in the future, what we have in the future to look forward to. So how to try to live forever, first do the obvious things. Eat healthy, live healthy, exercise, listen to everything your doctor says. But this isn't enough. This isn't going to allow us to do things like run 7-minute miles when we're 130 years old. And that's what we want to do. And by the way, we're not just talking about living longer, we're talking about living healthy longer. We want to be very healthy when we're in our hundreds. Now, there's been a lot of things that have allowed us to extend our lifespan tremendously, especially just in the last 100 years. In 1900, the average lifespan was only 47.3 years. And since then, we've extended that up to 78 years through a lot of things, including better sewage systems, vaccines, refrigeration, exercise. The other column has coronary artery bypass surgery, chemotherapy. All these things add up to give us a tremendous extension of life. But none of these things are going to cure aging. We still aren't going to see anybody, or we aren't going to be running 7-minute miles when we're 130 years old. And this is because there's a theoretical maximum lifespan that a lot of scientists have calculated to be 125 years. Apparently nobody can live beyond 125 years. There's been at least 3 studies done. The references are here. The most recent one was just a few months ago, a mathematical model looking at how much older people have been getting over the last 100 years, and still they see this threshold. We can't seem to pass this threshold of 125 years, and they don't know why. Most of you have probably never heard of a telomere, and so I'm going to give you a basic background on what this is first. And to do this, I need to zoom in on a person. And when we zoom in on a person, we see that a person is made up of 100 trillion cells. And all those theories I was talking about before on why we age, they all relate to the aging of our cells. We age because our cells age. If we could find a way to prevent aging in our cells, that would probably cure our own aging. If we zoom in even further, we see that every cell contains a nucleus. And inside these nuclei, there are chromosomes. And these chromosomes are where all the genes exist to give us our blue eyes or blonde hair, make some of us short and make some of us smart. And so I want to zoom in even further now and explain that a chromosome is made up of a DNA strand that extends from one end all the way to the other. And the DNA is approximately 10 million bases long. It's made up of units called bases, and it's pretty much coiled up like a slinky all the way through this chromosome. The key of my talk today is the very tips of the chromosomes. These are what are called the telomeres. And if we unravel this slinky in the telomere, we can see that a telomere is about 15,000 bases long. At least it is when you're first conceived. As soon as cells start dividing, your telomeres start getting shorter. And by the time you have enough cell division to become a newborn baby, the telomeres have shortened already down to 10,000 bases. They've gone from 15,000 bases to 10,000 bases. As cells start to divide further, for us to become adults, our telomeres shorten even further. And when they get as short as 5,000 bases, we die of old age. Telomeres cannot get shorter than 5,000 bases. Inside of petri dishes, when we grow cells in petri dishes, the cells absolutely stop growing and die of old age at 5,000 bases. Let me repeat this. We are born at 15,000 bases. We're conceived at 15,000 bases. We're born at 10,000 bases. We die of old age at 5,000 bases. And there's absolutely nothing we can do about this. This telomere shortening is going to occur no matter how well you exercise, no matter how well you eat, no matter how much you do everything your doctor tells you to do. You cannot stop this telomere shortening. Now, this is the only clock of aging that anybody has ever discovered in humans. And it actually fairly well explains this 125-year theoretical maximum that we have, because these telomeres shorten approximately 1,000 bases per year. So this is a new word. A lot of you now know what this word means, but I predict that in the next 5 to 10 years, this is going to become a household word. Everybody's going to want to know how long their telomeres are. I believe this is going to be the biggest and best biomarker of aging and overall health that we've ever seen. So the best example of where telomeres play a role in aging is the fact that there are some people who are born with already short telomeres. This disease, called progeria, affects these kids, and this disease is called the disease of short telomeres. These kids have a maximum life expectancy of about 20 years, and they suffer from all the same age-related ailments that normal old people do. If we could find a way to stop telomere shortening or to slow it down, this could be a cure for this disease. That's pretty much going to be what I'm going to be talking about today, is finding ways to stop this telomere shortening. Now, these kids aren't the only ones that suffer from telomere shortening. We all do. Telomere shortening has been implicated in almost all aspects of normal aging. And what I'd like to do is I'd like to just give a few examples, and I'll start off with the number 1 and 2 causes of death. Cancer. When our telomeres get short, our chromosomes become unstable, and the rearrangements of our chromosomes cause mutations, and these can induce the expression of oncogenes and de-repressed tumor suppressor genes, increasing our risk of getting cancer. In addition, when the telomeres in our immune cells get short, our immune cells lose the ability to fight the cancers. So it's two things happening here. Short telomeres increase our risk of getting cancer and decrease our ability to fight the cancer. Atherosclerosis. When you look at the cells lining your blood vessels, the endothelial cells and the smooth muscle cells, you'll find that if you look at the telomeres in the cells surrounding plaque, you'll find those telomeres are shorter than the telomeres in other parts of the blood vessels. And this is because we think that the cells have gotten older through telomere shortening, and as a result, they are less capable of preventing plaque. So if we could find a way to prevent that telomere shortening, this could be a possible way of preventing plaque and even fighting plaque. There's a lot of disease, lack of time. I'm not going to go into all of them, but people are welcome to talk to me throughout this conference. I can tell you the basics of telomere biology in all of these, but they include Alzheimer's, osteoarthritis, osteoporosis, just general skin aging. They include macular degeneration, which is the #1 cause of blindness in the elderly, liver cirrhosis, muscular dystrophy, AIDS. Now, you all remember back in the early 80s when AIDS epidemic first came around, doctors were saying that they don't understand why their patients don't have any T cells. But we now know that the immune cells, the T cells in the immune system, put up such a fight against the AIDS virus, and the fight was unsuccessful, but because of this fight there was lots of cell division, and the telomeres got very short in these immune cells, and the immune system died of old age, and that's why the AIDS patients don't have T cells. Now, if we could find a way to prevent the telomere shortening in these immune cells, the immune cells would stay around. They probably wouldn't be successful at fighting the disease, but the person might be able to live a normal life. General immunity, stem cells. Every time I go to a stem cell conference, doctors are asking me, have we come up with a drug to prevent telomere shortening yet? And I always have to say, not yet. But the reason why they're asking is because when you take stem cells out of a person, you have to expand them in culture. You have to get more numbers of them. You have to let them divide. Well, because of the cell division, the telomeres are getting shorter, and so the cells that they put back into a person end up actually being older than the cells they took out of a person. So people doing stem cells need a drug that will prevent telomere shortening when they're doing stem cell therapy. There's a lot of diseases. Anything you can think about that involves cell division is going to have telomere shortening. And one thing I want to leave you with is that bad things happen when telomeres get short. There's nothing good about short telomeres. And there's also nothing bad about long telomeres. So it would be good if we could find a way to keep the tips of our chromosomes long. So now let me address the question of why do telomeres shorten? And to do this, I have to explain, when I was showing you the cell and it had the chromosomes in it, when that cell divides, all the chromosomes, the two new cells that get made out of this have to have all the same chromosomes that the original cell had. So the DNA has to duplicate. It has to replicate. Now, DNA replication is a lot like laying bricks on a brick wall. The bottom strand here can be considered the original strand, and then the new strand, the top layer is the new strand, and this has to be identical to the original strand. Remember, this DNA is about 100 million bases long, so it's a long, arduous process. And if there's any mutations that are made during this thing, or any mistakes, this can lead to mutations that can cause cancer, etc. So this is a pretty accurate procedure. But what we want to do is we want to look what's happening over at the very tips of the chromosome. okay, the telomeres. And so we have this brick layer, which, by the way, in a cell is called DNA polymerase I, is moving along, replicating, and you're going to see there's a problem coming up here. And this is what actually happens inside of a cell. The cell is unable to replicate the very end of the chromosome. As a result, every time DNA or chromosomes are replicated, they are a little bit shorter. And as I said before, there's nothing we can do about this. But I want to point out that there was no degradation here. There was no enzymes that came along and shooed this away. This is purely due to a lack of an ability for the cell to replicate the very ends of the chromosome. It's more of a passive, not an active phenomenon. But now this DNA has to divide, or this cell has to divide, the chromosome needs to replicate again, the new chromosome is even shorter, and again and again. And there's absolutely nothing we can do about this. No matter how well you eat, no matter how much you exercise, no matter how much you do, everything your doctor tells you to do, you cannot stop this telomere shortening. I said you can't stop it, but there are things you can do to accelerate this telomere shortening. And this has to do with anything related to an unhealthy lifestyle. And that includes things like obesity, lack of exercise, psychological distress, and smoking. Things like those will create free radicals inside your cells that will come along, and the free radicals will clip your telomeres and make them shorter. Now, this kind of stuff you can control. You've probably seen press releases lately where people are saying that simple meditation can help reduce telomere shortening. Well, this is why. It's reducing the accelerated telomere shortening, but there's absolutely nothing that will work to actually reduce this basal level of telomere shortening here that I described first. So, how are we going to stop this? I've been saying that there's nothing you can do about this, but that's all I'm trying to do, is I'm trying to figure out a way to do it. And I've learned from a lesson from our reproductive cells. Our reproductive cells do not age. And this is important because if they did age, our children would be born as old as we are. But they don't age, and that's why our children are born young. So something inside our reproductive cells prevents them from aging. And so this was a key to try to find out how to make our other cells not age. Well, as it turns out, our reproductive cells do not have telomere shortening, and this is probably why they don't age. And this is because, we discovered this about 15 years ago, our reproductive cells contain an enzyme called telomerase. And this is a picture of a cartoon of telomerase. The green is the DNA, showing the very telomere tip of the DNA. And the factory-looking thing is the telomerase enzyme. And what it's doing there is it's lengthening the telomere. Now, so let's go back to this original model here of the brick layer as an analogy for DNA replication. This brick layer is still going to fall off in a reproductive cell. But like an angel, telomerase comes in and replaces that brick or fills in the missing DNA strand. So as a result, our telomeres don't get shorter. And if you think about it, it can't be getting shorter because you came from cells from your parents, they came from cells from your grandparents, et cetera, et cetera. Your children are going to come from cells from you. And if we had telomere shortening all the way through here, you would never, ever be alive right now because you wouldn't have any DNA left. There'd be so much telomere shortening. So our simple strategy in my labs is to take into account that first, somatic cells don't produce telomerase. That's the problem. But they do contain the gene for telomerase. So which means they have the ability to produce telomerase, they just don't. And they don't because the gene is shut off. And so our simple strategy, obviously, is let's figure out a way to turn it back on again. So inside the reproductive cell, telomerase is produced by the telomerase gene. And next to every gene, there's a regulatory element that's like a light switch that turns the gene on or off. In this case, in the reproductive cells, the gene is turned on. So in all of our other cells, a repressor comes along and binds to that regulatory element and shuts the gene off. And that's called a repressor. So what we want to do in my labs is we want to find a drug that will bind to that repressor, remove that repressor from the regulatory element, and allow telomerase to turn back on. If you decide you don't want telomerase to turn stay on forever. You can quit taking the drug, and the repressor will go back and shut it off again. So that drug would be considered an anti-aging drug. This is the team working in my labs, where there's about 30 scientists. We have a 10,000 square foot research facility in Reno, Nevada. We've been in operation now for 10 years. And we have $2 million robots that are spending all their time just screening drugs after drugs after drugs. And you can see like a robotic arm right there that will carry like 96 different drugs at a time, carry from station to station, and analyze, have equipment on this robot that will analyze the weather, see whether telomerase turned on. The key is, I want everybody to realize there's a very significant effort going on here to try to cure aging. And I have to admit, one of the main reasons this is going on is because I want to cure my aging. I'm very, very motivated by that. So we've been in operation for 10 years, and as of just a week ago, we have screened 141,756 chemicals, and we have now found 32 hits. That is, we have found 32 of these green things that dislodge this repressor. That is 32 different chemicals that turn on the telomerase gene. But this could be the biggest thing that ever hit the planet. Telomerase induction might just actually change the way all of us live if it works the way we think it's going to work. Now, this is probably where I should end my talk, because this is where we're at right now. But I want to say that we don't know the answer to this question yet. Will telomerase induction cure aging? It's all a theory right now. It's all hypothesis. And so we don't know the answer to this. But I want to say that there is a light at the end of this tunnel here. There is a lot of reason for a lot of hope. And that's because of proof of concept experiments that we have done over the years. Now, ideally, as I've been saying, we'd like to find a drug that would turn on the telomerase gene by just dislodging that repressor, but that drug doesn't exist yet. And so what we've done in the past is we've introduced the telomerase gene through a process that we call telomerizing. We take the gene, we insert it into the chromosome by carrying it on a virus, and then we do it in such a way that it's not regulated, and so that gene is producing telomerase. And so we've done that, and first let me say that when you take a normal cell, a normal skin cell, and grow it in culture, the x-axis here is the number of days in culture, and the y-axis is the number of cell divisions, you find that after a time the cells start slowing down and level off. This is called cell senescence, and that leveling off place is called the Hayflick limit. This has been true for all cells ever, but for the first time ever, when we telomerized human skin cells in 1997, we found that they did not level off. They kept on growing. Nobody had ever seen this before. These cells were the healthiest cells in the world, and they also had a tremendously decreased risk of getting mutations, including cancer. So we published this in 1998, made headline news all over the world, and it really opened the door for a lot more research on telomerase. But one big surprise in this study is that the telomeres didn't just stop shortening, as we expected. They actually got longer. So now this begged the question, did we actually make the cells younger? And this was not really our goal at the time, but let's take it. Now, the most exciting proof of concept is very recent data. This is proof of concept actually in humans. There actually is a commercially available nutraceutical that people can buy now for use in humans. And the company that's making this nutraceutical has provided us with some of it to do research on. And we have added it to cells, and we have found that it in fact induces telomerase expression. Not very much, but little is better than nothing. Even a little bit will at least decrease the rate of shortening. But now it might even be working better than we thought. In collaboration with another lab, we took blood samples from people that are actually taking this nutraceutical now, and looked at their telomeres, and even though we couldn't see the average telomere increasing. We could see that the shortest telomeres were increasing, which is telling us that this nutraceutical is inducing telomerase, and this telomerase is having an effect on the telomeres. When people that had been on the nutraceutical for more than a year were looked at, there were several different things that were seen. Some of these biomarkers a lot of you are familiar with, but CD28 minus T cells is one of the best biomarkers of aging, and they tend to increase when you get older. But the people taking this nutraceutical saw their T cells, CD28 negative T cells, decrease. They also saw naive T cells increase, natural killer cells decrease, blood pressure decrease, skin elasticity increase. This is really exciting. This is a real proof of concept that telomerase induction is something that can really be used to potentially cure aging. Now, we still don't know the question, will telomerase induction cure aging? And that's because this new nutraceutical hasn't been around long enough to really answer the question. But things are looking good, and I'm really looking forward to seeing what happens. We also still don't know the answer to how long we will live if we induce telomerase. But I predict that people will definitely live beyond the 125-year theoretical maximum. So, in conclusion, I'd like to say that Groucho Marx may not have been joking. Maybe he really did want to try to live forever. I know that I do, and I know that my company is very motivated to doing this. Our logo is Cure Aging or Die Trying.
Even though what Bill shared back in 2009 was exciting, since then, even more dramatic proof-of-concept experiments have been published by scientists from Harvard Medical School. But for me, the most critical experiment was the experiment that Bill Andrews and his team had done way back in 1997. Because for me, this experiment showed what happens to cells in perfect conditions. Dr. Leonard Hayflick had discovered way back in 1961 that a population of normal human fetal cells in a culture containing all of the essential nutrients will only divide somewhere between 40 and 60 times. Now, these are cells in perfect conditions. They've got all the nutrients they need. No oxidative stress, no psychological stress, no toxins. Just cells growing perfectly in a culture. Because what they found was that the telomeres just shorten with each cell division. And when they get down to 5,000 units long, the cells die. And adding more resveratrol, CoQ10, fruit extracts, antioxidants, glutathione, vitamins, colostrum, stem cells, or treated water makes no difference. These cells have already got all the nutrients they need. The only thing that had ever been shown to affect the Hayflick limit was when the cells were telomerized. And well, when the cells were telomerized, functionally they became immortal. They just kept dividing and basically until they filled the Petri dish. Forever. And this work was published by Dr. Bill Andrews and his team back in 1998. And when they looked at the telomeres, what they found was the cells didn't just stop shortening, but they actually got longer. And this caused the scientists of the day to ask the question, does this mean that the cells had got younger? Well, really, that question was answered definitively by a group of scientists from Harvard Medical School led by Dr. Ronald DePino, when they published on the 28th of November 2010 in the peer-reviewed journal Nature, research demonstrating for the first time that turning on telomerase and lengthening telomeres will reverse the symptoms of old age in a living animal. It's important to understand what they've said here. They didn't say they would slow it down. They didn't say it would stop it. What they said was that it actually reversed the symptoms of old age in a living animal.
And now, eternal youth. Is it in a cage around the corner? News tonight of a breakthrough for some pioneering mice. But we always wonder, what does a fountain of youth for rodents reveal for humans? Here's Sharon Alfonsi reporting.
I feel tremendous.
In the movie Cocoon, it's a swimming pool that turns back the clock for a group of senior citizens. But now researchers have found a way not just to stop, but reverse the aging process. The key is something called a telomere. We all have them. They're the tips or caps of your chromosomes, seen here in yellow. This is what it looks like in a young adult. But as you grow older, the telomeres become damaged and frayed, and as they stop working, we start aging, experiencing things like hearing and memory loss. Scientists took mice who were prematurely aged, added an enzyme, and essentially turned their telomeres back on. You can see it before the enzyme after.
Their brain function improved, their fertility was restored. It was a remarkable reversal of the aging process.
Look at this picture. The mouse on the right has bad skin, gray hair, and is balding, but the one on the left had its telomeres flipped back on.
And you could see that essentially you now have a dark coat color, that the hair is restored, that the coat has a nice healthy sheen to it.
Even more dramatic, the change in brain size. This is before. The mice had 75% of a normal brain, like a patient with severe Alzheimer's. But after the telomeres were reactivated, the brain returns to normal size. As for humans, while it is just one factor, scientists now say by looking at our blood cells and measuring those telomeres, you can get a better idea of how well you'll age. The longer the telomere, the better the chances for a more graceful aging.
Later, Dr. Ronald DePino stated, these results prove that aged tissues have a point of return and can regenerate if critically short telomeres are lengthened. And Dr. Bill Andrews said, these were results that, if seen in elderly humans, would constitute a successful reversal of the aging process. And he said, just as telomerase activation reversed degeneration in the organs of these mice, we expect that it can do the same for humans. As best scientists can tell, lobsters show no measurable signs of aging. They have no loss of appetite, no change in metabolism, no loss of reproductive urge or ability, and no decline in strength or health. I mean, how good would that be? Lobsters, when they die, they seem to die from external causes. They get fished by humans, eaten by seals, wasted by parasites, but they don't seem to die from within. Lobsters possess the fountain of youth. And in humans, telomerase is only found in some types of tissues. But in lobsters, telomerase is found in all types of tissue. And with a steady, evenly distributed supply of telomerase, lobsters don't approach the Hayflick limit, which means their cells stay pristine, young, and dividing. And that's why a big old lobster in a restaurant tastes just as good as a smaller one. And that doesn't happen with beef or lamb or chicken. You see, lobsters don't age. And what scientists have also found is that lobsters don't get cancer. I mean, what scientists believe is their immune system stays functional and healthy for their entire life. I can't tell you how excited I was when I found out about lobsters and realized that God had already created one animal in which the gene to produce telomerase had been turned on in every cell in its body, and that animal was doing extremely well. Dogs, cats, and horses also age by telomere shortening. So to summarize, the science is really very simple. Telomeres are our body clock. They shorten with normal cell division. Telomerase is an enzyme that causes the telomeres to lengthen. And a gene to produce telomerase is present in every body cell. And telomerase production can be switched on by substances known as telomerase activators. And bad things happen when the telomeres get short. So really that covers the basics of telomere biology. And Isagenix product B that we're going to talk about now is not a drug. It's not intended to diagnose, treat, cure, or prevent any illness or disease. And this video is for training purposes only, and these statements have not been evaluated by the FDA. To me, this is an incredible story of how two brilliant scientists working in completely separate fields were divinely brought together for the benefit of all mankind. In studying all I could about these two men, I realized that both exhibited compulsive, obsessive behavior type patterns driven by an intense desire to discover and implement scientific strategies whereby people could live a longer and healthier life. They very clearly were not driven by the almighty dollar. Peter Greenlaw, an Isagenix associate who lectured internationally on nutrition, had heard about the work that Dr. Bill Andrews was doing. And after many attempts, he was finally able to arrange a meeting with Bill in June 2010. Peter was very excited about what he had learned about telomeres and Bill's research, and he arranged for Bill to speak to John Anderson. Now, John Anderson is a renowned natural products formulator. He's been in the nutraceutical industry for 33 years as a manufacturer and formulator of natural supplements. During that time, he has formulated more than 2,300 products for over 600 different companies. He is the founder and master formulator for Isagenix. And John is recognized as a world expert in the field of extracting the active ingredients from plants. After speaking to Bill Andrews on the phone, John Anderson then flew out to speak to Bill and to examine in detail the research and the facilities that Bill and his company at Sierra Sciences had in Reno, Nevada. Bill and his team of scientists at Sierra Sciences have been looking for telomerase activators since 1999. It took them over 6 years and 57,000 tests to find the first one. Now remember, it only took Thomas Edison 10,000 tests to invent the electric light. By 2010, Sierra Sciences had screened over 300,000 compounds. Up until then, they were trying to find a pharmaceutical, a drug, or a chemical. They had found some, as Bill mentioned in his A4M lecture, but they were not suitable for human consumption. In referring to their first meeting, John stated, Bill said, "We use a control that actually turns on the gene that expresses telomerase. It's very strong and very potent, but it's not for human consumption." And this answered my next question, which was, why wasn't it on the market? So John and Bill then decided to collaborate and have undertaken the challenge of finding inducers of telomerase in vitro utilizing natural plant-based botanical ingredients. Dr. Andrews' test involved running John Anderson's natural ingredients through a machine that measures whether or not an ingredient produces a hit, which is the equivalent of inducing telomerase. The machine does this by comparing the test ingredients against a control that turns on telomerase activity. Unfortunately for humans, that control is too toxic for consumption. "I wanted to have a hit as big as the control," John Anderson said. Bill told me it was impossible. The control was so strong we were never going to see a hit like that in a natural botanical. But loving a challenge, John Anderson sent Dr. Andrews 80 to 160 vials every week for screening. All Dr. Andrews knew about the vials was that they differed somewhat in ingredients and potency. John Anderson's hard work finally paid off with an exciting phone call from Dr. Bill Andrews in early March 2012. "You've exceeded our control. I can't believe it. What are you doing over there?" said Bill Andrews over the phone. Bill Andrews and John Anderson get together, 2 different areas of expertise, and magic happens. In August 2011, John Anderson had shared publicly and discussed openly the results obtained as a result of the collaboration between he and Dr. Bill Andrews.
September 23rd, I sent in the first 15 samples that I prepared and very carefully selected for screening. And here's what happened. Can we play the first recording?
Hi, John. This is Bill Andrews. Well, I sure wish you answered the phone. I've got a bunch of scientists here standing around all excited because one of your compounds was a hit. Tell me when you can. All right, we're all excited. You
why were the scientists so excited? Because Dr. Bill Andrews and his team had tested over 300,000 compounds since 1999, and this was the first time they had found hits that were immediately suitable for human consumption. And this was due to adding John Anderson's area of expertise. All of the samples tested were derived from plant-based botanical extracts. And so in August 2011, Product B was released. It is a brand new, totally unique product. It contains over 25 active ingredients, some of which have been shown to induce telomerase in vitro. Now, in vitro lab results may not be indicative of in vivo results. Product B also contains vitamins, antioxidants, and anti-inflammatory compounds. In 2013, Product B was listed with the Australian Government Therapeutic Goods Administration, the TGA, as a telomere support product. And this is the only product recognised by the TGA as providing telomere support. Product B helps maintain youthful function of cells and healthy telomeres so you can age youthfully. Who are our potential consumers? Well, it's anybody wanting to maximise their health span. It's people wanting to maximise their lifespan. Athletes, because normally they'd peak out fitness-wise at about 25. In fact, it's everyone. It's very simple to use. It's just a matter of taking 2 capsules twice per day. There's 120 capsules in a container, and so one container lasts one person 1 month. It works out at less than $100 per month, and there's volume discounts available. Isagenix have a 30-day money-back guarantee, so you can just try the products. You've got nothing to lose. It's now been available since August 2011, and thousands of people worldwide have already begun to feel and see the benefits of taking Product B, including increased energy, improved fitness, improved mental clarity, sleeping better, look better, and a general feeling of youthfulness and vigour.
Hello, I'm Margot Mott. I'd like to share with you a little story of my life that has made significant changes in my life. I started off as a very young girl as a model. I became Australia's Mannequin and Model of the Year 2 years in a row. Needless to say, I've always been health conscious, and during the period of my career, very successful career, I noticed changes, significant changes by the time I hit 40. But 45 was a very, very stressful time of my life. Both parents became ill, and it was 18 years of nursing my mother and my father particularly. And during that stressful period, it certainly showed on my face and my skin. The energy level had actually left me. So many things troubled me. And I think when you get to that stage of your life that you think, wow, it's all too much, you have to really act upon how you feel. So from my beautiful world that I once knew in Korea to another world which was very depressing, very sad, and the hours that I spent in taking care of my parents and my own business career, it played havoc on my life. I was very fortunate to meet Product B in my life. What was most significant were the changes in the 18 months. I thought, no, this can't be true. It cannot happen. But it was certainly a great difference to me when I saw and felt was the biggest thing, the feeling of seeing myself change in 18 months. Really surprised me. I became more aware of my health in the sense that I felt fantastic. Absolutely fantastic. But the big thing was noticing it in my skin. That's a significant change. My actual skin started to feel more youthful. I mean, it works for everybody differently, I guess, but what is important here, when I really look at my life and how it has effectively improved my life, now, of course, talking about in the 60s years of age, my beautiful dog, Diesel, was the greatest change for me to witness. I'd like to share that with you. And this is my beautiful dog, Diesel Eve. She's a female blue heeler, and she turned 18 years of age 3 days ago. Now, Product B has been the most wonderful thing because I was very sure that I was going to lose her at least before this Christmas. And she's been now on it for 5 weeks. I give her 1 tablet in the morning and 1 in the afternoon, 1 at night before she goes to sleep. The big thing that's happened to her, for an old girl, is that she has no more tear ducts, no more dirty eyes. I have not wiped her little face in 3 weeks out of the 5 weeks, believe it or not. She's more alert. She can hear the front doorbell. She now barks. So she's back to being a security dog. I
house. I have a bird. I haven't fed the bird yet. But the big thing that really excites me is there's two big things, apart from her eyes and her awareness. She's more aware and more alert than ever before. She slept more than she was awake, is her back. And I'm going to share that with you very shortly.
Diesel had a tumour removed surgically from her back 15 months prior to commencing Product B. The hair that had been clipped by the vet had never grown back.
This is all new hair. Look at this. All brand new hair. Like, that took only 3 weeks to 4 at the most to grow. And before that, it was as bald as can be. So I'm so excited about the fact that all her hair is growing. It's wonderful.
But I really want to show you something else that's been an incredible thing. For the last 9 to 10 months, she has not been able to run or trot. It's been a very slow walk, and when she stops suddenly and sits and says, that's it, I've had enough. So I'm going to show you something. This is very exciting for me to see her actually physically have a bit of a gallop up.
One of the things I love about giving Product B to animals is the fact that there is no placebo effect in an animal. The animals simply don't know what they are getting and or how they are meant to behave.
Hi, my name's Donna Burgess. I did a lot of athletics from the age of 5 to about 20. I then gave up, ventured in a few other sports, and decided to come back at the age of 47 into athletics. And I've been running now for 3 years, and I've just had a lot of success. World Masters Games, winning 3 gold and a silver medal. Product B I was introduced to about 6 months ago. The national championships were coming up. My brother suggested that I take some or get on it. So I took some for 3 months and had won 3 titles at Canberra at the Nationals and broke an Australian record. My coach, when we returned, wanted me to head off to Italy to the World Masters Games. So I decided to stay on Product B for another 3 months, and I had great success at Italy. So I just felt so much better, a lot more energy at training, slept a lot better, and just in myself felt really good. So I think Product B had a lot to do with all my success in Italy, for sure. I won a gold medal in the 400 metres in the women's 50 to 54 section, also ran a personal best time. Won the 800 metres for the women's 50 to 54 and also did another personal best time, so couldn't be happier.
Poi c'è la tedesca Zul, che è la giuria, Manuele che va al punto, vince 64-34 per l'australiana, tedesca seconda, la giuria terza, quindi questo è il podio con la vittoria della donna più che l'australiana, la tedesca Esther Zul e la giuria Silvia.
The other 2 medals were in the 4x1 relay and the 4x400 relay. So we were training 5 sessions a week. 3 were track and 2 were at the gym. The track sessions varied anywhere from half an hour to an hour and a half, just depending on what we were doing. Sometimes the sessions weren't very long, but very, very intense, and the recovery was very important. That's where I think Product B has come in and helped for sure. Yeah, I don't think I would have been able to maintain the 5 sessions a week. Now, we did that for just on 12 months. And before that, we were doing a lot of training too, but the last 12 months has been very, very intense training. So, yeah, so I think at my age, 51, it's quite hard to do, but yeah, I think Product B has helped tremendously.
Why call it Product B? Because it's been estimated that as more people learn about and understand the importance of telomere biology and also hear about what Product B is doing for people who are consuming it, at least $1 billion in sales will be generated. It's going to be huge. Many scientists predict that a human should be able to live to 125 years of age. God in his word said, "My spirit shall not strive with man forever, for he is indeed flesh. Yet his days shall be 120 years. And I was excited to see that both God and the scientists functionally saying the same thing. I was even more excited to find out that Jean Calment, a French lady, has already lived to 122 years of age. So it's not theory. And Moses was 120 years old when he died, yet his eyes were not weak nor his strength gone. Now, it's important to remember that our lifespan has already increased in the last 100 years from 47 to 78 years due to a whole heap of different factors. This is a massive 65% increase. And I now believe future discoveries and inventions will enable this trend to continue. I was a 59-year-old ex-veterinary surgeon when I was first told about telomere biology in 2011. Initially, the whole concept that Dr. Bill Andrews was discussing completely defied my core beliefs regarding the aging process. I mean, it defied what I'd been taught as a veterinary student, and it certainly defied what I was already starting to experience personally. It also defied what I'd seen happen to my parents and to many others. The more I studied it, though, the more convinced I became that it was based on solid scientific experiments performed by very well-respected scientists, that there was definitely something in it, and it was certainly something I wanted to try. During the first 9 days of intense study, the idea gradually dawned on me that possibly I could have at least another 40 years of good health. When that finally sunk in, I've got to tell you, I got very, very excited. You see, I guess at least at a subconscious level, I'd been thinking that as a 60-year-old, I probably only had about 20 years of declining health left. I can assure you that to now think of 60 as only being half-time and not three-quarter time has made a huge difference to how I view the future and how I live each day. I mean, for example, here's a photo of me getting ready to play a game of AFL Nines football in December 2012 at the age of 61. At that point, it was 30 years since I'd last played a game of footy. I kicked 3 goals and had a lot of fun, right? And the good news is I was even invited to play again in the next game. Having studied this topic for over 2 years now, knowing how much fitter and more youthful I feel since taking Product B, and having heard many stories from literally hundreds of other people who have also been taking it, I now believe it is possible to have at least another 40 years of good health. Not only do I believe it is possible, but I believe I have a responsibility to help educate others also. The purchase of Product B each month need not just be an additional cost. It can be the basis of an additional income stream. If you share the story and help others get healthier, you get paid. Thank you for taking the time to watch this presentation. For more information regarding Product B, please get back with the person who shared this information with you. For a better understanding of telomere biology, it's suggested that you watch this video again. Remember, your life depends on your telomeres.